Hi. I thought I should talk to you a little bit about more JavaScript stuff. Your focus should be on completing the midterm. So please do that above anything else. There is the first JavaScript assignment, and there's another couple of assignments that I'm going to release, but midterm is the highest priority for now. So we talked about JavaScript to start with. Let's go into things in a little bit more detail. And one thing we need to understand about JavaScript is that despite its name, it's based more on a language called Scheme than it is on Java. And Scheme is a functional programming language. So it's more interested in functions rather than variables or objects or statements. Right? Objects, you might have heard of object-oriented programming. You may have heard of imperative or procedural programming. This is another paradigm, another way of thinking about programming, and it's all about functions. And it's an alternative to object-oriented programming. Now, JavaScript is not a fully functional language, but it does support a lot of the nice features of functional programming languages. And this is a little bit of an introduction to it. Right, so one thing that you've got to remember is that functions are variables in JavaScript. Right, so here we have a function called say hello, and we can look at the type of say hello, and its type is function. So we can say, we can assign say hello to a variable, right? And that's a really powerful thing. This simple example, you can see that now instead of saying say hello world, we say greet world, and it sends console.log hello, world to the console. Another thing we can do in JavaScript that is kind of interesting is we can use what are called anonymous functions. This function here, say hello, is not anonymous. It is a named function. It's called say hello. It's got a name. This version is an anonymous function. We can't do it this particular way because you can't reference this function anyway. We can't use it anyway. But we could use it this way and assign the variable say hello to be this anonymous function that we just defined. So you can make a named function either by explicitly naming one or by assigning an anonymous function to a variable. Right, so here are the two ways. It's just an empty function. The function doesn't do anything. It's the thing between the curly braces. But these two are functionally equivalent. right? So the only difference is one of ordering. JavaScript will put variable and function declarations into memory before it executes any of the file. So it'll use those declarations to figure out how much memory it needs to allocate. In practice, you should always declare and define functions before you use them. So put them at the top of the file, and that reduces the impact of hoisting. Another thing you can do is you can add functions to objects. Here's an object called of a dog. It's got a name, Sparky, it's got a breed of mutt, and then we can add an anonymous function to the bark property of the dog to makes it go woof. You could also do something similar this way, right? Let Fido equal this, and name of Fido, bark, which is a function. You can do something with Spot, and both of them do something, but Fido woofs and Spot yips. Another thing you can do with functions in JavaScript is you can pass them to other functions, right? And one way to think about this is a callback function, right? So here's our say hello function, and here is a do with world function, and we're passing in a function into do with world, right? And so when we call do with world, we pass in the say hello method, and then it gets executed because the variable func to call is assigned the value say hello. And calling say hello with world will print out hello world. So that's the way it hangs together. So be careful not to put parentheses after the say hello. If you do, that tells the JavaScript interpreter to execute the function say hello rather than just treat it as a variable. So here's an example. If we go call console.log with just greet, then it prints out this is a function. But if we call greet inside the log function, then this gets executed and we get hello printed out instead of the function greet. Oftentimes a function that you pass to another function is called a callback function, right? Because it gets called back somewhere in the function. And you don't have to just have a single callback function, you can have multiple callback functions. And that idea of passing a function as an argument to another function is at the heart of functional programming. Sometimes you can pass a function in and that function is an anonymous function, right? So before we defined say hello, and we call do with world say hello, and that all works. But here we're calling do with world, but we're defining the function we're passing in as part of the parameter. This definition of the function is an anonymous function. All right, we haven't named it anything. It has the same effect as the say hello version, but sometimes it's easier. And as it says, be aware that those last two braces, that last curly brace is the closing version of that one. So the fun thing, not only can you pass in a function as a parameter to another function, the return value of a function can also be a function. Right? So here's a way to make a greeter function, and here's the greeter function, and we just return it from the make greeter function. Right? And we can say hello and the greeting is hello, or we can say howdy and the greeting is howdy. So when we say hello, we get hello world or hello Dave. When we say howdy, we say howdy world or howdy partner. So the most significant part of this example is the scoping of the greeting variable. Right? Scoping means where it's valid. However, here, right, normally you'd think that local greeting will go away. Right, this one here is what they actually mean by local greeting. You'd think that this would go away after you leave here, but it doesn't, because it's this part of it that gets bubbled up as the return type. Right? So it effectively remains in scope. It remains available after the function returns. Another interesting thing about functional programming is a different way from for loops to do looping. Right? This is pretty standard way of doing a loop. For I equals 0 to less than the array length I++, right? That's a standard construct in a lot of languages. But the nice thing is in JavaScript that when you have an array of objects, there is a method called for each that will is built in, and it will let you call each of the elements of the array in turn, or rather apply a given function to each of the elements of the array in turn. Right, so here's an array, and we're calling the for each function of the array, and all we're doing is for each item in the array we're going to print it out on the console. Right? That's pretty interesting. Another similar thing is the map function. This applies a given function to all of the elements of the array. So here we define a function that squares the argument it's given, and then we have a numbers array, and we could just loop through that and square each of the numbers. But the map function gives us a shorthand way of doing that, right? I hope you'll agree that this way of doing it is a lot more long-winded than this way of doing it. Right? This way we can pass in a value, pass in an array and then get the square of the array back using the map method of the numbers array. So the major difference between the for each method and the map method is that map will return each element. So if you need to create a new array, you should use .map, but if you just need to do something with each element, use the for each. Another thing we probably want to do is to filter out elements from an array. And here's an example of just finding the even valued elements of the numbers array. And we're doing that by creating an isEven method. But arrays in JavaScript have a filter method available. And that filter method, we just pass in the function we want to use to indicate true for the elements we want, and we just pass in isEven, and it'll return an array with just the even numbers in it. We could even pass in this isEven method as an anonymous array, right? And now we have a one-line function to do the same thing. And because map and filter are called on, but also produce arrays, you can call them in the same method. So if you want to both find the even numbers and square them, then I don't know whether that's right. This one doesn't have 6 in it. Anyway, you can just do one after the other and it should produce the same result as doing them each separately. Another operation you can do is reduce. Right? And this is like combining all of the elements of an array together in some way. Here we've got an add function, and what reduce is doing is it's going through the array and adding each element to each previous element so that we get the sum of the elements in the array. Right, so reduce will not return an array necessarily. In this case, it's only going to return a scalar value, the sum of the numbers in the array. And reduce doesn't have to start at the beginning. We could start summing from 10 instead of 0. Right, so here's an example of how you might use map, filter, and reduce with emoji and appropriately defined functions. Cook is vegetarian and eat. So pure functions, first class functions, are central to just about any functional programming language. However, there's more to it than just callbacks. And pure functions have these qualities, right? They operate only on their inputs and have no state. No other information is used except what is given to them as input. They never change their inputs. They just return new data. There's no side effects. They don't modify any other variables elsewhere in the program. If you give them the same inputs, they will always return the same output, regardless of what's happened. That's, again, to do with state. There are additions to JavaScript that let you do more serious functional programming. Lodash, Ramda, or lazy.js. I'm not going to talk about them here, but you should have a look at them if you're interested. Okay, that is the next chapter about functional programming in Java. Look out for the next assignment. There is one available already. It's under group project because reasonably soon we're going to move into the project phase of this course, where we're going to use the stuff we've learned about HTML, about CSS, and about JavaScript to do a separate project in a group. The first thing I want you to do is to just organize yourselves into 5 groups of 5 people. So please accept this assignment and have a read through this. You will see that there are, if you are the first person to click on this link, you'll be able to create the first group. If you're the second or subsequent person, you may be able to either join an existing group or create a new group. Once there are 5 groups created, you won't be able to create any more groups and you will have to join an existing group. Please get that done at some point. The main priorities for now are the midterm, right? That's due on October 24th and there's no grace period. Actually, that's the wrong course. Let me get the right course. Right, there we go. Right, I'm going to add this video to this list shortly. Please do the group assignment. The things you should be doing are finalising the peer review assignment that's due on October 24th, finalising the midterm that is also due on October 24th, and then doing this animation for the Super U assignment images that is due on October 31st. Okay,